In this third chapter, we're going to talk about how to change the default font on the spectrum. In other words, the desync of the letters that are printed, which, as well as being used as text, can also be used as graphics. The spectrum has 96 printable characters defined in ROM. Each character is made up of an 8 per 8 pixel matrix. These pixels can be on or off. If they are on, they will be shown in the color set by the ink command, and if they are off, in the color set by the paper command. This means that normally a character can only have two colors, ink and paper. Characters are stored without color information because they take the color from the current ink and paper. By storing only on or off information, we save a bit of space. So, in memory, each row of 8 pixels is stored in 1 byte, which has 8 bits, meaning no memory wasted. A character has 8 rows, so a character takes up to 8 bytes in memory. If we multiply 8 bytes by 96 characters, we get 768 bytes, which is what a completed character set occupies in memory. However, if we're not going to use all 96 characters, we can define only the ones we need. For example, in our game, only uses uppercase characters, numbers, and a few special symbols. There is no need to create or store the rest. On the other hand, we can use character sets as graphics, going from 19 or 21 GDUs up to 96 characters. So let's create our own font by creating a project called font test inside the ch-tools-projects folder, as we have already seen in the previous chapters. We set main file to main.bas, as we always do, and click on Accept. Now we create a new file in the graphics category of type ch font file, and we call it myfont.fnt. As you can see, the editor is similar to the GDU editor, with the difference that patterns contains 96 characters ranging from 32 to 127. It works in exactly the same way as the GDUs, so I refer to the second chapter of this course to learn how to use the editor. Today I want to create a cool font for my game, so I'm going to look for some inspiration. Careful, inspiration is not the same as copy or plagiarism. On the 1001 Fonts website. On this website you will find thousands of fonts and plenty of inspiration. The font Karma Future caught my eye, so I'm going to try to make something similar. As you can see, it is a font with relief and shadow. Let's see how it turns out. I'm going to start with uppercase A just to begin with something simple, and I'll start with two letters to have a reference. Then I place the top point, I outline the rest and the inside, and I add the shadow. Well, it turned out better than I expected. So let's move to the letter B. In this case, I use the technique of outlining the default letter, creating a halo around it and tweaking the details until I get the desired effect, or something as close as possible. We continue with Z. And with the rest of the letters. When you have two very similar letters, such E and F, or Z and G, you can copy and modify them. Well, for the moment I'm happy with the numbers and the uppercase letters. Let's save and open the export dialog. We are going to export as dim, which for now is the most convenient option, with the file name myfont.fnt.bus and the name myfont. We click on Save Options and our dim is generated. To see how it looks, let's create the file mine.bus in the code category of type chbasic file. The first thing we need is to add the font to our code with sharp include myfont.fnt.bus. Then we adjust the system variable chars so that it points to our new font, taking into account that we have to subtract 256 from the start address. This is because printable characters start at ASCII code 32, which is the space, and 32 per 8 equals to 256. Poke integer 23606 my font 0,0 minus 256. This is an integer poke that is 16 bits to address 23606, which corresponds to the system variable chars, with the start address of our new font, determined by my font, minus 256 bytes mentioned before. Next, we print something using a simple and classic print. Print, this is my font, 1, 2, 3, 4, 5. We run it with F5 and we will see the text printed using our new font. And here is an interesting detail. If we now press the OK to enter execution, we'll see BASIC itself working with our new font. Now let's look at an example of a font with a roll effect. In this case, we will use the Spectrum's default font, but we'll play around with it to achieve a curious effect. The project is called AirPrint, and you can find it at boriel-basic.net. The first thing we do is to define a variable called sysvarchars of type uinteger, located at memory address 23,606. This allows us to avoid using poke. Although it's really almost the same as using poke, and poke is very fast, this can be useful in some cases. Then we call the main subroutine, which we created next. In this subroutine, we call the AirPrint subroutine, indicating the row and column where we want to print and the text to print. Next, we play around a bit with the colors, setting the paper color to yellow, the ink color to red, and then printing again by calling AirPrint. Finally, we define AirPrint subroutine, which takes three parameters: the row, the column, and the text to print. Inside this subroutine, we defined the variable charger with the value 3C00, which is the address of the Spectrum default font. If you want to use your own font, just replace 3C00 with the address of your font minus 256. Do not forget to subtract 256. We also define a variable n of type byte. Note that I use it byte and not ubyte because we need it to be able to hold negative values. We implement a loop that goes from 7 down to 0. Because of that, 0 n has to be of type byte. That is, what's between 4 and next will repeat 8 times, with n taking the values 7, 6, 5, 4, 3, 2, 1, and 0. Then we adjust the variable sysvarchar so that it's point to the address of the font, adding the value of n, which goes from 7 down to 0. This shifts the font pointer from 7 to the correct position. This is the equivalent to doing a poke. We print the text at the row and column passed as a parameters to the subroutine. We pause for 100 milliseconds using the pause 5 command. Each pause unit is 20 milliseconds because it is synchronized with the screen refresh, which happens 50 times per second. That is, every 20 milliseconds, 1 second divided by 50. So, in short, pause 5 is the maximum pause of 5 per 20 milliseconds, which is 100 milliseconds. If it seems too fast, or you want to see the effect in more detail, you can change the pause value. For example, with 50, which is 1 second. We run it, and here is the effect. Finally, let's see how to print fonts in two different colors. As I mentioned early in this chapter, a character can only have one in color and one paper color, but the mprint project, which you can find at borielbasic.net, shows how to get around this limitation in the simplest possible way without using matching code or interrupts. What mprint actually does is print one line with the top 4 bytes of the font and on another line and a different color the bottom 4 bytes of the font. Let's see in a practice. We open the font myfont.fnt. We select the uppercase letter A, change the width to 26 and adjust the thumb so that all fonts are visible. Now we copy it, we select the lowercase letter a and paste. This way we duplicate the letters from A to Z. Without changing the selection, we move the patterns upwards without a roll 4 times. We select the uppercase A and move it downwards this time 4 times. So basically, the uppercase letters are the top part, while the lowercase letters are the bottom part. Now let's move on the numbers. We select 0, we change the width to 10, We copy it, select the exclamation mark symbol and paste. Now we use net is to move it upwards 4 times. Switch back to 0 and move it downwards 4 times. We define the export properties, checking that everything is correct. And this is the listing I'm going to explain, which can be found in main.bus. The first thing we do is add the font definition with an include. Then we call the main subroutine. In this main subroutine, we set the screen border to color black, the paper color, which is the screen background, to black, and in color to white. We clear the screen and set the system variable charge to the start address of our font minus 256. Then we call the mprint subroutine twice to print two tests with different colors for the top and the bottom parts. The mprint subroutine is where the magic happens. It takes the parameters row, column, test, color 1, the top color, and color 2, the bottom color. We define three variables of type ubyte. N will act as the loop counter. Z will store the character to print as we are printing character by character. And L will store the length of the text minus 1. L works as upper limit for the loop. And although it is not strictly necessary, since we could just use len txt minus 1, that will cause length txt minus 1 to be recalculated each time through the loop. By storing it in a variable, it's not recalculated on every iteration. We create a loop from 0 to the length of the test minus 1, which is why we start at 0. We obtain the ASCII code, that is the ordinal value, of the character at position n. We set top color and print at e, x the character we read early. We use chr to convert the ASCII value of C into its corresponding character. Keep in mind that Z does not store a character, but its numeric value. For example, 65 for the A. So if we print C directly without the CHR, it will print 65 instead of A. We set the bottom color. Here we perform a series of operations to determine the character to print in the bottom part. If it is a number, 0 has ASCII code 48 and 9 has ASCII code 57, we subtract 15 from the ASCII value. So 0, which has ASCII value 48, becomes 33, which is the code for the exclamation mark, where we place the bottom part of 0. If it is not a number and it is a letter, that is, its ASCII code is greater than or equals to 65, the ASCII code for A, we added 32. This turns an uppercase A, for example, into a lowercase a. Once these adjustments are done, we print the new character one row lower. Pay attention to the detail of the semicolon at the end of the print statements. This detail speeds up the printing. If we do not include the semicolon, the system performs a carriage return with a line fit, having to calculate the next line and determine whatever it needs to scroll the screen upwards. By skipping these checks, we significantly increase printing speed. In short, to speed up printing, we end print testament with a semicolon. We run it with F5 and we can see our fonts in two colors. Well, I hope you like it, and I recommend visiting the official Boriel Basic website at borielipenbasic.net, where you can find the listings for this chapter.